Canned tuna, tasty, convenient, and nutrient-dense, has become a pantry staple for everyday meals. From refreshing salads and grab-and-go sandwiches to savory fried rice and light fresh spring rolls, canned tuna is the perfect choice for whipping up something delicious in minutes. Beyond great taste, tuna is a nutritional powerhouse. Packed with protein low in saturated fat and especially rich in omega-3 fatty acids, DHA and EPA, tuna helps protect heart health while supporting brain and vision development. Canned tuna isn't just popular in the United States, it's enjoyed worldwide with more than 7 million tons of tuna caught each year by fleets from over 70 countries. But have you ever wondered how canned tuna is made? Join us as we explore each step of the process, from freshly caught tuna on the open ocean to the high-quality product that ends up on your grocery store shelves. The search for tuna schools across the vast open ocean is more than just a job. It's a thrilling high-stakes adventure. On modern fishing vessels, crews slice through the waves, venturing far across endless waters while tracking the movements of these remarkable fish. Known for their strength and speed, tuna often travel in massive schools, creating an impressive force beneath the surface. In the middle of the open sea, pole-and-line boats and purse seiners follow tuna using sonar and fish-finding equipment, combined with satellite data on sea surface temperature and nutrient-rich waters. These tools can detect tuna at various depths, enabling fishermen to pinpoint the exact location of a school. Once the fish are found, the captain decides whether to use pole-and-line gear or a purse seine depending on the conditions. A tuna fishing trip is never short. Each voyage can last from 30 to 45 days, during which the catch is flash frozen on board to preserve peak freshness, ensuring the tuna retains its premium quality by the time it reaches the processing plant. When the tuna arrives at port, it is immediately transferred into the plant's processing area using conveyor belts and specialized forklifts. Here, each fish undergoes a strict quality inspection. They are sorted by size and weight and carefully checked for freshness to ensure they meet the standards before moving on to the next stage. Once approved, the pre-processing phase begins. Skilled workers precisely remove the head, belly, and internal organs. For larger tuna, the fish are cut into smaller sections to make them easier to handle in later production steps. Using sharp saw blades, experienced workers cut the tuna into uniform blocks. Each cut must be consistent, quick, and precise to maintain the fish's best quality. After portioning, the tuna is neatly arranged and thoroughly rinsed to remove any remaining impurities. This cleaning step is crucial, ensuring that the final product is flawless, free from residue or contaminants, and ready for the next stage of processing. After thorough preparation, the tuna pieces move on to a crucial stage: cooking. To preserve the fish's natural flavor and nutritional value, steaming is the most common method. In this process, massive trays up to 45 feet long and capable of holding as much as 22,000 pounds of tuna are loaded into specialized steam chambers. The tuna is cooked at high temperatures using a combination of steam and direct heat, ensuring even heat distribution throughout each piece so it cooks evenly from the inside out. The steaming process typically lasts between 45 and 120 minutes under high pressure at temperatures ranging from 212 degrees to 230 degrees. This helps remove excess fat while locking in the tuna's natural flavor. At the same time, it softens the skin and bones, making them easier to remove later in the process. Once steaming is complete, the tuna is transferred to special cooling chambers to lower the temperature and remove excess moisture. This cooling stage not only helps maintain the fish's quality, but also ensures the final product remains fresh without becoming overly soft or dry. Once the tuna pieces have cooled, they are moved to the next processing area where the natural aroma of the fish still lingers in the air. This stage demands precision and skill from experienced workers. At the cleaning tables, the process of separating the meat from the skin and bones begins. Each tuna with its complex structure contains hundreds of tiny bones and fine spines. Workers must carefully remove them by hand, ensuring that no impurities remain on the meat. Razor-sharp knives are wielded with absolute precision, each movement swift yet delicate to create flawless cuts of tuna. The skin is also meticulously removed, enhancing both the texture and appearance of the product. Every piece of tuna, once fully separated from skin and bones, undergoes a thorough inspection. Workers check each piece to ensure it is not only clean, but also meets exact standards for size and quality. After the deboning process is complete, the pristine tuna pieces are placed on a conveyor belt ready to continue their journey through the next stages of production. Canned tuna is produced in a variety of can sizes and shapes to meet diverse consumer needs, with round cans remaining the most common and easily found on supermarket shelves. In large-scale production, the process of filling round cans with tuna is fully automated, maximizing efficiency and ensuring the highest level of precision. Once the tuna has been fully prepared, it is moved along a specialized conveyor system to a dedicated filling station for round cans. Here, an automated system evenly and accurately dispenses tuna into each can. This mechanism not only guarantees that every can contains the exact standard amount of tuna, but also ensures consistent product quality, providing consumers with complete satisfaction. To preserve the tuna's freshness and flavor over time, liquid must be added before sealing the cans. Depending on the manufacturer's recipe, this liquid may be vegetable oil such as canola or sunflower oil or brine. These liquids not only extend the product's shelf life, but also enhance the tuna's distinctive taste. Next comes the can sealing stage, carried out with precision and airtight security. Before the lids are attached, the cans pass through an exhaust chamber where hot steam forces out excess oxygen. Then, a double-seam sealing machine secures the lids, creating an airtight seal. At this point, all air inside the can is completely removed, helping the product maintain its freshness, preventing bacterial growth, and ensuring the tuna remains safe throughout its shelf life. To keep the process running smoothly and at peak efficiency, the entire operation is closely monitored by a team of skilled workers. The packaging machinery not only delivers exceptional accuracy, but also operates at remarkable speeds, sealing anywhere from 100 to 800 cans per minute, meeting the demands of large-scale production while maintaining outstanding quality in every single product. Once sealed, the tuna cans are neatly stacked into specialized metal racks, ready for one of the most critical steps in the production process: sterilization. This is a key stage to ensure food safety, extend shelf life, and preserve the product's flavor. The racks of cans are loaded into retort machines, where the temperature reaches 240 degrees to 250 degrees for a carefully calculated period, depending on can size and recipe, to achieve the required thermal safety level. When sterilization is complete, the hot cans are transferred to a water cooling system to bring down the temperature. At the same time, this step removes any dust or steam from the surface, giving the cans a clean, polished appearance. Next, the cans pass through an X-ray machine to detect bones or metal fragments. Only then are they labeled. To guarantee absolute quality, strict quality control procedures are enforced throughout the entire production process. Each day, quality inspectors open representative samples from the previous day's production batch and sort them for testing. These samples are sent to the laboratory to examine texture, nutritional content, and food safety indicators. This inspection process ensures that every can of tuna reaching consumers meets the highest standards of quality and safety. After passing rigorous quality inspections, the standard-approved tuna cans move on to an important step to ensure transparency and traceability. Using advanced laser technology, the batch number production date and expiration date are precisely and clearly etched onto each can, allowing consumers to easily track the product's origin. With the product information in place, the cans enter their final decorative stage. Product labels, eye-catching illustrations, and key details are carefully applied to each can, creating an attractive and professional appearance designed to win over consumers at first glance. Once labeling is complete, the cans are meticulously packed into sturdy cardboard cartons, then neatly stacked on pallets. They are now ready for their long journey to consumers, ensuring that each can of tuna reaches the right place into the right hands, delivering a safe and delicious meal. And that brings us to the end of the tuna production line. From raw catch to a finished can, every step is driven by precision, hygiene, and industrial-scale efficiency. But tuna is just one example of how the seafood industry transforms ocean harvests into products enjoyed around the world. Because beyond canned fish, there's another side of seafood production, one defined not by speed and volume, but by value, rarity, and tradition. Along the cold, rugged coastline of Maine, a very different seafood journey takes place. Here, the focus isn't mass production, it's one of the most valuable and closely regulated seafood products in the world: lobster. They grow slowly in the icy waters of the Atlantic, which gives their meat a rich sweetness and firm texture. Lobsters are one of the most unique crustaceans when it comes to growth. They have to molt. That's right. Unlike humans, who grow gradually, lobsters must completely shed their hard shells in order to keep growing. Imagine if every year we had to take off our entire skeleton to get bigger. That's exactly what lobsters do. The process begins when their hard shell starts to crack along the back. At that point, the lobster pulls back and wriggles out of its old shell, including the claws and other parts. Then it enters a new phase, a larger, softer body that's surprisingly vulnerable for a short period of time. Fascinating, isn't it? And did you know it takes a lobster between 5 and 8 years to grow big enough to reach the legal harvesting size? Their growth journey is anything but simple. The state of Maine, with its cold, stormy Atlantic coastline, supplies about 90% of the entire U.S. lobster catch, an enormous figure of nearly 100 million pounds each year. Lobstering here isn't just a job, it's a long-standing tradition deeply tied to the coastal fishing families of New England. Every early morning before the first light of dawn, fishermen prepare their boats and head out to sea to continue the work their families have done for generations. Commercial lobster fishing begins with a simple but crucial step: setting traps. These traps, called lobster pots, are placed on the seafloor at carefully chosen locations to lure lobsters in. For bait, fishermen use pogie, a small, oily, and strong-smelling fish that lobsters can detect from a distance underwater. Once the traps are dropped, lobsters start picking up the scent. If it's appealing enough, they follow the trail and slowly crawl inside. But the process is not quick. The soak time of the traps is calculated carefully to make sure the lobsters don't leave before they're hauled up. A typical day on a lobster boat involves checking around 300 traps. These traps are usually arranged in clusters of 6, tied together with a long rope. Each end of the rope is marked with a buoy in distinctive colors. This serves as the unique signature of each fishing boat. When the lobster traps are hauled out of the water by mechanical winches, the sorting process begins immediately. It's a precise and strict task for the fishermen. Any creature other than lobsters, stray fish, or curious crabs is gently released back into the sea. Even the smallest fish are treated according to this rule. Lobsters are sorted on the spot by size. Undersized lobsters under 3¼ inches and oversized ones over 5 inches are returned to the ocean without exception. The reason isn't about taste, but preservation. Small lobsters haven't reproduced yet, while large lobsters are vital breeders that sustain the population. Both must be protected. If a fisherman finds a female carrying eggs, she isn't just released. A small V-shaped notch is carefully cut into her tail. This mark identifies her as a breeding female and signals to all fishermen, don't keep her, whether it's egg season or not. It's a protective tag that helps ensure the survival of future generations. Once sorting is done, market-sized lobsters have their claws secured with specialized tools and rubber bands to prevent them from injuring each other during handling. They're then gently placed into foam containers filled with seawater that matches the ocean's temperature and salinity, keeping them healthy until they reach the processing plant. Step by step, these carefully handled lobsters continue their journey, from the vast ocean to elegant dining tables. When lobsters arrive at the processing plant, their next journey begins with the stunning stage. The plant uses high-pressure processing, HPP, a modern non-thermal method that stuns and kills lobsters quickly and gently. The HPP machine applies pressure up to 50,000 psi, strong enough to kill the lobster without causing pain. It's considered one of the most humane methods available, showing full respect for the animal. Beyond stunning, the immense pressure of HPP also breaks the bond between the lobster's meat and shell. This makes meat removal much easier. More importantly, because no heat is used, the lobster's natural flavor, texture, and nutritional value are fully preserved. The technology also ensures top food safety by eliminating harmful microorganisms without chemicals or high temperatures. Right after stunning, lobsters move to the separation stage. The tails, the meatiest part, are removed and carefully processed, while the claws, bodies, and remaining parts are sent down a conveyor belt to industrial steamers. Skilled workers then clean, devein, and prepare each section of meat, ensuring it meets premium quality standards and is ready for market. After separation, the lobster claws and knuckles go through a special steaming process to produce high-quality cold-picked meat. The claws and knuckles are placed into steamers where the temperature is tightly controlled to ensure consistent quality. This steaming process not only eliminates spoilage-causing bacteria, but also loosens the meat from the shell while preserving its natural sweetness, tenderness, and texture. Here's what's remarkable. This method extends the shelf life of lobster meat from 10 days to up to 18 days, while maintaining the same fresh ocean-caught flavor. After steaming, the meat is hand-picked. This stage demands precision and care. Workers carefully remove every piece of shell and cartilage to ensure a clean, premium product. With advanced processing technology and skilled craftsmanship, the meat recovery rate can reach up to 90%, an impressive figure in the seafood industry. The lobster meat is then vacuum sealed to preserve freshness until it reaches consumers. Finally, the fresh lobster meat undergoes HPP, high-pressure processing once more, a natural technique that extends shelf life without compromising quality. Impressively, the facility can produce up to 10,000 pounds of cold-picked claw and knuckle meat every day, ready to supply fine dining tables around the world. Next in the processing line, the lobster tails move to the grading area. First, they're sent to a specialized station where a modern machine plays a key role: weight classification. Each tail travels along a conveyor belt where precise sensors automatically weigh it to the gram. The smart system then sorts the tails and directs them into different bins according to weight category. These bins are then sent to the freezing section for the next stage. Here's where it gets interesting. The lobster tails are moved into a special nitrogen freezing tunnel, a cutting-edge technology. Imagine nitrogen acting like an ultra-thin protective layer around each tail, shielding it from sudden temperature changes. This process locks in protein quality, freshness, flavor, and texture, preserving the lobster meat as if it had just been caught. All fresh products processed the same day are carefully packed, weighed, and sealed, but nothing ships out immediately. Each batch undergoes a final quality check within 2 days to ensure no change in freshness or quality. It's quite a meticulous journey to bring lobster to our tables, isn't it? It's a meticulous journey, one that reflects the value of every lobster long before it ever reaches the table. And yet, in the world of premium seafood, lobster is only part of the story.
Beyond the cold waters of Maine, another giant dominates the frozen seas. Larger, heavier, and even rarer, the king crab stands at the top of the luxury seafood world. With its massive size, long legs, and sweet tender meat, the king crab is among the most expensive seafood products on the planet. But behind its spiky shell lies an unexpected ecological story. This species primarily lives in icy waters, particularly the Bering Sea, where temperatures can drop to as low as 20 degrees. However, what's interesting is that they are not native to the Norwegian Sea. In the 1960s, the Soviet Union introduced king crabs to the Barents Sea, hoping to exploit the resources of the cold deep waters. The result, an ecological disaster beyond expectations. With no natural predators to control their population, king crabs reproduced at an alarming rate. They are scavengers preying on other bottom-dwelling creatures, disrupting the food chain and causing severe imbalances in the ecosystem. What started as a project to harvest economic benefits quickly turned into an invasive species issue. Yet this very characteristic has made them incredibly valuable. King crabs can weigh over 26 pounds with legs extending up to 5 feet, making them the largest crabs in the world. Their meat is soft, sweet, and rich in protein, making it a delicacy at fine dining restaurants worldwide, with prices reaching hundreds of dollars per pound. In Norway, where they are most heavily harvested, the government has enacted strict regulations. Once caught, fishermen are prohibited from returning them to the sea to prevent further environmental damage. Another interesting fact, king crabs only have 6 legs. Unlike the usual 8 legs of other crabs, they can live up to 30 years. Throughout their lives, they molt between 15 and 20 times, each molt making them bigger, stronger, and more expensive. Autumn in Alaska is not just the time when the leaves change color. It's also when the most intense king crab hunting season of the year begins. As the first cold winds of the season start to blow, fishing boats leave the harbor, heading towards the deep waters of the North Pacific about 200 miles off the coast. The fishing season lasts only 2 to 3 months, from October to January. But don't let the short duration fool you. This is one of the most dangerous and grueling jobs on the ocean. On each boat, fishermen use metal traps weighing between 660 to 880 pounds, reinforced with steel mesh. These traps are not only strong, but smart. Only large, market-sized crabs can enter them. Smaller crabs have their own escape routes, a way to ensure the long-term preservation of the species. The bait herring or cod, the kind that has started to decompose and emits a strong odor, a scent the king crabs cannot resist. Once ready, the traps are lowered to the ocean floor from 200 to nearly 1,000 feet deep, connected to ropes with buoys floating on the surface to mark their locations. Each boat is equipped with a flexible crane system, allowing for safe and efficient movement and lowering of the traps. Each boat can drop hundreds of traps, creating a vast network in the frozen ocean. After 24 to 48 hours, when the traps are full, the real game begins. The fishing boats return to the fishing grounds to retrieve the heavy traps from the cold waters. Using hydraulic cranes, the crew pulls each heavy trap onto the deck. The retrieval process requires precise coordination and care to avoid accidents or damage to the traps and the crabs inside. Cold water splashes everywhere, the wind howls, and one by one, the massive spiny crabs begin to emerge from the steel mesh. As soon as the traps are opened, the crabs are transferred to sorting trays, ready for the next step. This is not just fishing, it's a battle with nature demanding strength, patience, and a bit of daring. As soon as the king crabs are brought onto the deck, the sorting process begins immediately. This is not only the first step in the processing chain, but also a critical part of protecting this valuable seafood resource. Each crab is manually inspected according to strict standards. Too small, throw it back into the sea. Carrying eggs, not allowed to keep. Only crabs that meet the proper market size, typically between 6 to 11 pounds, are kept on the boat. Some crabs can even weigh over 22 pounds with leg spans exceeding 5 feet. Truly the kings of the ocean. The sorting process requires high precision and speed. Large trays on the deck are specially designed to hold large quantities of crabs, allowing the crew to easily sort and handle hundreds in a short amount of time. Once sorted, the crabs are placed into special seawater tanks. These tanks are designed to mimic their natural habitat, cold and oxygen-rich, helping the crabs stay alive and, more importantly, maintain their freshness as if just caught. Each fishing trip usually lasts about 3 to 4 days. This is the optimal time to ensure the crabs stay healthy when the boat returns to port. Freshness is not just a standard, it's a must if the crabs are to meet the high-quality demands of the premium market. When the boat returns to the dock, the crabs are carefully unloaded and immediately transferred to specialized refrigerated trucks. From there, the journey of the king crabs continues, from the cold waters to modern processing plants. As soon as they dock, the crabs are taken to modern processing plants, where every step is strictly controlled in terms of temperature, sanitation, and processing speed. This ensures that every crab leg that reaches the consumer meets the highest standards of quality and food safety. The first step is critical, separating the legs from the body without breaking or crushing them. Skilled workers place the crabs into specialized machines, where special blades carefully detach the long legs intact. But that's not the end. Attached to each leg is the gill, which must be removed immediately. Thanks to a rotating gill removal system, workers only need to gently rub the crab legs against the machine. The gills are quickly and cleanly removed. Next comes the cutting station, where each crab leg is separated into smaller pieces for processing. Here, the precision of the workers is crucial, as even a slight mistake can cause the crab meat to crack, reducing its quality and value. However, modern technology is gradually changing this process. Some leading factories have developed fully automated crab separation systems, using visual sensors and smart algorithms to precisely locate the joint positions. Machines can now handle crabs with near-perfect accuracy, preserving the meat inside without breaking the shell or wasting any material. Automation not only speeds up the process, but also ensures large, consistent production volumes, especially during peak seasons. This is a significant advancement for the seafood processing industry, where the combination of human skill and technology is setting new standards. After being processed, the king crab legs enter another crucial stage, cooking and freezing. This is the moment when the natural flavors are locked in and preserved down to every muscle fiber. First, the crab legs are carefully placed into large mesh baskets, which are then slowly lowered into a hot, industrial water bath maintained at 185 degrees, about 85 degrees Western. After about 30 minutes, the crab meat is perfectly cooked, tender, yet still sweet, and with the characteristic firm texture. Immediately after cooking, the crabs are transferred to a cold water bath, a thermal shock that locks in the freshness while preventing bacterial growth. The next step is rapid freezing. The crabs are immersed in a brine bath at a temperature of about 18 degrees. In less than 40 minutes, each crab leg is fully frozen, ready for long-term storage without losing its flavor. To add an extra layer of protection, the crabs are dipped in fresh water, where a thin layer of ice crystals forms on the surface. This thin ice coating helps prevent dehydration, keeping the crab meat from drying out or deteriorating during storage. Finally, the crabs are removed from the baskets, carefully packaged into plastic bags and cardboard boxes, and transferred to a cold storage facility with optimal conditions. Now the king crabs are ready to be shipped to high-end restaurants, seafood markets, and someone's lavish meal in a faraway place. So you've just followed the meticulous journey of the king crab, from the wild icy waters to the exquisite dishes on a banquet table. You may have already tasted this delicacy, or perhaps you're dreaming of the chance to try it. But now you know the effort, technology, and even the sheer determination behind that spiky shell. Do you enjoy this dish? How do you usually eat it? Steamed, garlic butter, roasted, or raw, like sashimi? Feel free to share in the comments. And if you found this video interesting, don't forget to like, subscribe, and hit the bell so you don't miss the next fascinating behind-the-scenes journeys.